Okay, so here's another video on kinematics. Without any delay, let's jump on directly to the question. The question states that a student drops a small metal object into a cylinder of oil. The object falls alongside a vertical ruler and a camera records its position at 1 second intervals as shown in figure 1.1. So these are the 1 second intervals and they've shown us the figure. Now on on the grid in figure 1.2, plot a distance time graph for the object. So we just need to draw a distance time graph, and before that we just need to simply plot the values. So I take the first time instant when time t equals 0, the distance was 0. So this is going to be my first point at time t equals 0. So somewhere at this region. Somewhere here. Now the next value at time t equals 1 seconds is around halfway between 0 and 1 centimeters, which might be 0.5 centimeters. So let's go to that part, and for time t equals 1 the distance became 0.5 centimeters, so that becomes our second point. At time t equals 1 distance equals 0.5. Yeah, so this becomes my second point. Now I go on to the next point, and if I look closely, so this is not touching 1.5, rather this is 1.6, a point just next to, sorry for that, if you look closely, this is not touching 1.5, rather it's at a point just next to 1.5, which is 1.6. So at time t equals 2 seconds we need to go to 1.6. So time t equals 2 seconds and I go for 1.6. How I know it's 1.6? These are 5 blocks and these 5 blocks equals 1 centimeter. So obviously if I need 1.6 centimeters, so it should be 3 blocks above 1 centimeter. This is my second point, and then let's go to the graph again. Third point at 3 centimeters. So at time t equals 3, at 3 centimeters, at time t equals 4, I'm at 5 centimeters, and at time t equals 5, I'm at 7 centimeters. So time t equals 5, I'm at 7 centimeters. So here we go with the graph, and I've plotted them. Now I don't know why this point keeps moving. So the first point was at 0.5 seconds. Now the thing is, we would have gone for a straight line, but if you see, it's not possible to draw a straight line. Whenever you draw a straight line, you can't possibly connect all the points by just drawing a straight line. That's not possible. This seems more like a curve. So that's what we do. We connect the points in the form of a curve, and this becomes something like this. Now if you remember from distance time graphs, so a graph like this represents increasing gradient. And what's the gradient of a distance time graph? It's speed. So this graph, this pink graph, represents increasing gradient, which is increasing speed in this case. So the speed is increasing, and what's that thing, what's the quantity, with the name of the quantity which is present when speed increases? That's acceleration. So basically the ball which fall was accelerating towards the ground. It has an acceleration because of which its speed was increasing, and the increase in speed was shown in a distance time graph. So that's what they wanted to do, and that's what we've done. Now in the next part they tell us that the object has a constant speed for some of the time. State and explain how a distance time graph shows that speed is constant. How would a distance time graph show that speed of an object is constant? You don't need to go to the previous graph. They're not asking us to explain and show how that previous or how the distance time graph shows. Rather, how any distance time graph would show me that the speed of an object is constant. How do we show that? Simple. The distance time graph, for it to show constant speed, what should be? It should be a straight line that passes through the origin. So a straight line, a straight non-horizontal line that passes through the origin. This type of a line represents or shows speed that is constant. Very simple as that. Now the next part, explain in terms of forces acting on the object. How is it able to fall at a constant speed? So this part is related to terminal velocity and part of the dynamic part, the dynamic section of forces of this Newtonian physics section. So we will be ignoring that for the moment, and if we do so, we're done with the question. And I hope this is clear to everyone.